Assalamualaikum. Today we would like to present our final project about University Accommodation Management System. Before we begin, here are the members of our group who contribute to this project. Now, let's move on to the presentation.
My name is Izati. Today I will present the system development methodology and project charter for our project. Our project title is University Accommodation System or UniAccom. For this project, we choose the waterfall model as our system development methodology. The waterfall models follow a structured and sequential process where each phase must be complete before moving to the next phase. The 6 phases are requirement gathering, system analysis, system design, system implementation, system testing, and system deployment and maintenance. We selected this model because the project requirements are clear and fixed, making it easier to manage, monitor progress, and complete the project within the academic timeline. The main objective of this system are to manage student accommodation application and room allocation efficiently, verify student eligibility and room availability, allow students to submit maintenance requests online, improve communication between student and housing staff, and generate report to support administrative decision-making. The scope of the system includes user authentication, accommodation application, room assignment, maintenance request management, inquiry handling, and report generation. However, it does not include payment processing, off-campus housing management, or integration with third-party booking platforms. The key stakeholders are university students, housing management staff, university administration, and the IT department. Finally, the project deliverables include the project proposal, system analysis and design documents, context diagram, EERD, interface design, system prototype, final report, and group presentation. That's all for me. Thank you.
My name is Nur Amirah Natisha and I will explain the design phase. Based on the Gantt chart, the design phase starts from week 6 until week 14. During the phase, we focus on designing the system before development. So the main activities include ERD and data dictionary design in week 6 and 7, followed by UI design in week 8. This activity helps ensure the database structure and user interface are properly planned. Overall, the design phase provides a clear foundation for the implementation of the UniAccom system.
My name is Nohani Umaira, and I will explain the context diagram for the University Accommodation Management System or UniAccom. This diagram provides a high-level overview of the system and shows how it interacts with external entities. There are 3 external entities involved, which is student, housing staff, and university database. The student interacts with the system by submitting accommodation application, login details, maintenance requests, and inquiries or message. In return, the system provides application status updates, room assignment notification, accommodation information, and maintenance updates. The housing staff receive accommodation application maintenance requests and student inquiries from the system. They also send occupancy information, room assignment updates, maintenance management information, and communication response back to the system. The university database supports the application process by providing student eligibility data when the system sends a verification request. Overall, the context diagram shows the main data exchange between UniAccom and its external entities without showing the internal processes. Next, I will explain the level 0 data flow diagram, which breaks down the UniAccom system into 5 major processes. The first process is manage accommodation application. Students submit accommodation application and login details. The system verifies student eligibility through the university database and stores application data in the student and application records data store. The second process is manage room assignment. Approved application information is used to assign rooms. Room assignment data is stored in the room and assignment records data store, and room assignment notifications are sent to students. Housing staff also provide occupancy information and assignment updates. The third process is manage maintenance. Students can submit maintenance requests, which are recorded in the maintenance and communication records data store. Housing staff receive these requests and provide maintenance updates. The fourth process is manage communication and support. This process handles student inquiries and message, manage communication with housing staff, and store related report records. Finally, the last process is generate accommodation reports. It collects application, room assignment, and operational data to generate reports that support accommodation management and decision making. In summary, the DFD Level 0 illustrates how data move through the system main processes, data stores, and external entity to support accommodation application, room allocation, maintenance management, communication, and reporting. That's all from me.
Hello, my name is Natalia and I'll be explaining the Level 1 DFD of the data flow of a student housing assignment and maintenance system. There will be three key entities, which is the students, university database, and housing staff. This is our Level 1 DFD as an example shown in the screen. Three of them act as the main data source and destinations. And then there's a fourth data store, which is the process route processed data through D1, which is student and assignment, D2 room and assignment, D3 maintenance, and D4 reports. Then they separate into more detail, which is the subsystem flows. For example, the system is segmented into application receipt, room selection, maintenance tracking, and inquiries.
The first relationship is between student and application. A student can submit multiple accommodation applications over time, but each application belongs to only one student. Therefore, the relationship between student and application is one-to-many. The second relationship is between accommodation and room. Each accommodation, such as dormitory or apartment, contains multiple rooms. However, each room belongs to only one accommodation. Therefore, this is also a one-to-many relationship. Next is the relationship between student, room assignment, and room. A room assignment records which room is allocated to a student. One student can have multiple room assignments over time, and one room can be assigned to different students over time. The room assessment entity acts as an associative entity linking student and room. Therefore, student has a one-to-many relationship with room assignment, and room also has a one-to-many relationship with room assignment. The maintenance request entity is related to both student and room. A student can submit multiple maintenance requests, but each maintenance request is submitted by one student. Similarly, a room can have multiple maintenance requests, but each request is associated with one room. Therefore, both relationships are one-to-many. The maintenance task entity is used to track action taken to resolve maintenance requests. One maintenance request may involve multiple maintenance tasks, which each maintenance task is linked to one maintenance request. In addition, one staff member can handle many maintenance tasks, but each maintenance task is assigned to one staff member. Therefore, both relationships are one-to-many. The communication entity facilitates interaction between student and staff. A student can send multiple messages, and a staff member can also send or receive multiple messages. Each communication record is associated with one student and one staff member. Therefore, student has a one-to-many relationship with communication, and staff also has a one-to-many relationship with communication. Finally, staff members are responsible for managing room assignment. Therefore, one staff member may manage multiple room assignments, which each room assignment is managed by one staff member. This forms a one-to-many relationship between staff and room assignment.
Next, I will explain the input design of the UniCom system. The input design is developed to ensure accurate data entry, reduce user errors, and provide a better user experience. First, for the login form, users are required to select their role, either student or housing staff, before accessing the system. This password file is also must to protect user credentials and improve security. Next, for the student accommodation application form, important information such as student ID, full name, program, and year of study is also automatically retrieved from the university database. This helps prevent incorrect data entry and saves time from users. In addition, the accommodation and room type file use drop-down menus that only display available options. This reduces mistakes and ensures that students can only select valid choice. The form also includes a text area for special requests or medical preference, allowing students to provide additional information when necessary. Overall, this input design is well organized, easy to use, and help users complete the application process quickly and accurately.
And I'm going to explain the output design of the University Housing Management System. Now for the student dashboard, the main body of the page shows an application history section. The area gives students updates on their requests, where we can see a green badge marking an application as approved, the red badge as rejected, and the yellow badge for pending requests. Below each status, clear metadata is provided, including the unique application ID, the specific block, and room type.
Thank you for watching our presentation. We hope it has provided a clear overview of the University Accommodation Management System.